Yeah, so I think we can start. Hello again, my name is 𝗀𝗲𝗻𝗄 and I'm the event manager of AI Startup Rising. Nice to have you all here. Today I'm the moderator and I will give you some facts about Sarah. Afterwards, Sarah will tell us about what to do when starting an NLP project. Sarah Holschneider is head of NLP at L1 Systems located in Darmstadt. She has her roots in translation studies and computational linguistics. Sarah started at L1 Systems in 2017, being the only NLP person in the company back then. The need of NLP expertise became obvious and increased in the following years. Today, Sarah will tell us about her experiences from the first project idea and the right team composition to the finished application. So I'm very excited. Thank you, Sarah, for being here. Nice to have you here. So I think I will hand it over to you.
Thank you for having me. So as Yasmin already mentioned, my name is Sarah Holschneider. I'm working for L1 Systems as head of NLP. We are a software company based in Darmstadt, and well, we are specialized in NLP and also doing other software projects, but in my position as head of NLP, I'm here today to tell you a bit more about NLP projects and how to start one. I will post that slide in the end of the presentation again, so you don't have to screenshot it. In case you want to contact me afterwards, you will have another look at it. Our topic for today is what to do when starting an NLP project. And I decided to structure my presentation in a way that we first dive into what is NLP, because I don't know if everybody is from that branch of computer science, to give us a common understanding on what we are actually talking about. Then we will dive into 3 projects shortly. Well, we cover one a bit longer, and then we will draw our conclusions out of the things we mentioned when describing the project. So what is NLP? NLP is short for natural language processing. I mention that every time when I do a presentation because many people confuse it with neurolinguistic programming, and that it's not what we are talking about in our context. It's a subcategory of computer sciences, and it's concerned with the processing of natural languages. It's not equal to artificial intelligence. This is another misconception that sometimes goes through people's minds. Although we use techniques of machine learning, it is not the only aspect. Also, speech recognition is a subcategory, but not the only application where NLP expertise is needed. Usually when you tell people about natural language processing, things like Alexa and Google Home come into their minds, but that's only one application that is possible. And by the way, something that we do not do at L1 Systems. Why do we handle natural language differently from other data science projects? Well, we have a few special characteristics when it comes to natural language. First of all, it's naturally grown, meaning it's not defined and then used, but while people were using it, it's, well, developed. It's constantly changing, therefore. We have no well-defined semantics and many layers of interpretation, meaning probably every one of you already had the situation that you said something, but the person you were telling something received it in another way. So, well, this is because there are different ways of interpret human language, because it's dependent on context. Also, different document types follow different conventions, meaning dependent on if you have a formal contract or an essay, people use different conventions to structure their thoughts, to structure their language, and it's not only about grammar and style and wording. But today we're not talking about NLP in general, we're talking about NLP in business. And this differs a lot from NLP in academia. Like some of you might have listened to the talk by 𝗀𝗽𝗲𝗿𝗂𝗿 a few weeks ago. where he mentioned things about, well, what aspects come into join the game when you want to publish something, an NLP paper, an NLP research paper. Academia follows certain rules, business follows different rules. This is because, first of all, an investment for an NLP project is always an investment for saving money on the long run. There are usually no publications, so we don't have to find out what do we have to write down to have it published. Usually it's not open source, neither the code nor the data. The data is usually not publicly available, and generalization is not as necessary as it is usually in research papers, because companies want to save their money, so they want to have a product that serves their needs, not necessarily other companies' needs. So they don't want to save other people's money. That's also why sometimes overfitting is not as bad in many cases. The ones of you who come from computer linguistics or computer science departments probably learn at university overfitting is bad. Well, usually it is bad, but when you're developing a very specialized software tool, sometimes it's overfitting that you need to make your customer happy, as absurd as it sounds. Also, customers are often driven by trends, and this is kind of poison for your expectation management. It's very important that your customer can distinguish between the trends that are out there, may it be deep learning or certain big data models, and what can actually be achieved for his or her use case. So let's come to my 3 examples I want to show you. First of all, the first example is about the generation of clinical study reports. It's based in pharmaceutical industry. I'll talk more about that later. The second example is the digital engineer by naltrexone. This is the implementation of a chatbot that guides engineering students through a course on how to build a satellite from scratch. And my third example is the prediction of the health status of individuals based on a database that captures certain health parameters. During the course of this project, we will find out certain do's and don'ts that occur when you work in an NLP project. But first, we need to cover the basis for the first project, the generation of clinical study reports. Clinical study reports are the documents that are, amongst others, to be handed into authorities like FDA or EMA when you want a drug to be administered. It's part of the drug admission process. And this CSR, clinical study report, is a mix of 3 documents. The CSP, which is the clinical study protocol, the SAP, statistical analysis plan, and TLFs, which is basically the tables where you capture all the data that you measure during a clinical trial. The CSP is like a cookbook where the study is described, how it should happen, and the SAP is where the methodology is described before the study starts. I realized that someone unmuted him or herself. Do you have any questions?
No, sorry. That was just a issue. Thank you very much.
Okay, no worries. So we started that project with the following situation. We had no clue at all about the drug admission process. Pharmaceutical companies are not prone to voluntarily share their data. The publicly available documents are often outdated. Guidelines as well as formats change during time. The industry loves MS Word and PDFs and does not stick to one version. Also, documents which were available had been produced with different templates. I have to somehow get this picture smaller so that I can see my slides. And this had an impact on the content. So overall, the dataset was insufficient, as it is often the case in data science projects. Still, it was communicated that it was supposed to be a machine learning task, but we realized I will come back to that later. Not everything was inherent to the data. There was a certain human upper bound because different medical writers, that's how this the profession is called, medical writing. Different writers have different working styles. And also the formatting of output documents happen to be crucial. So people not only want to have the correct content, they also want it to be formatted in a certain way that satisfies their needs. Either way, we started our project with optimism. We parsed the available documents and contained the hierarchy. We used common pre-processing steps, split everything into sentences, for example. We trained machine learning algorithms to predict which sentences or paragraphs belong to which section. And we thought that we succeeded. We had an accuracy somewhere over 90%, showed it to the customer, and the customer said, well, that's nice, but actually that is not what we needed. And that is when our optimism decreased. Let's go more into detail. I was talking about pre-processing steps. The ones of you who are more focused on the business part, you will later understand why I go so much into detail about that pre-processing. Usually when you have an NLP project, you start pre-processing steps such as tokenization, that is splitting the text into words, or segmentation, that is splitting a text into bigger segments or smaller ones, lemmatization, that is leading something back to its lemma, so the way it is written in the dictionary. And we have a bunch of other pre-processing steps. You don't have to use everything independent of the project. It always depends on the project you have, which pre-processing steps you use. For example, part of speech tagging is when you assign the word Wortarten in German, like verbs, nouns, etc., the parts of speech, to words. And I once needed that when I wanted to transfer a text from present tense to past tense because I had to find out where the verbs are. So these are the things that are normal in an NLP project. But in reality, a bunch of other pre-processing steps join the game. As I already mentioned, we were working with MS Word. And most of the techies hate Word because there are so many weird things that you can't see. And exactly this is what happened to us. We parsed everything, even went into the encoding of Word, the XMLs that lie behind. But even when we thought we cared about special characters, for example, there were certain special characters where we always faced issues. For example, this one. It's a lesser equal sign. And probably most of you already Googled it once to find out how to type that it looks like this. We tried to parse it, but every time it occurred again in our documents, it looked differently. And then we sat together with our customer and we were talking about certain numbers, how they should behave. And suddenly he said, oh yeah, this is lesser equal, and started to type in. And suddenly it was like mind-blowing for us because we realized there are so many ways of writing this character into a document. Voila. So version number 1 would be you write a lesser sign, then you mark it and make an underscore below it. I still can't relate to this one. The other version was you make a table, for example, in Excel or in Word, and then you only display the lower boundary of a cell, and voila, you have a lesser equal sign. And yeah, there's still the possibility to insert pictures into documents. Why am I telling you this? It's crucial to know how your customer works or your user, because they might find creative ways to go around the standard or the ways you are supposed to use certain tools. Going further with pre-processing, we went further into details and tried to find out where certain aspects of the text were ending up in the output document. Unfortunately, I can't show you the real life data, so I extracted an example of university times. Annotation. You need labeled data for most machine learning tasks. Oh, not for most, but for certain. And in this case, we wanted to find out how the users were actually doing their work so that we could somehow understand it. And we started to annotate. Annotation means you label texts. In this case, it's just POS annotation. For example, Michael would be named entity, Eigenname, 𝗀𝗪𝗂𝗁, the same, and you go through that text. A human being has to do that so that we gather training data for an algorithm. This would be a rather easy task in this case, because most people know parts of speech from school, so there's not a hard limit on which people you can choose for your annotation team. But there are also more complex tasks, such as this would be POS, this would be sentiment analysis annotation. I took this example from the 𝗀𝗽𝗲𝗿 2017. Sentiment analysis tries to capture who is describing, no, not who, if certain utterances are positive or negatively connotated. For example, we have here 𝗀𝗽𝗲𝗿𝗲𝗿, sorry, it's not an English example. And the customer wanted to know to which category the positive or negative utterances were belonging. There we face the issue that people interpret things in a different way and structure also their thoughts in a different way. That's why you usually need more than one annotator for a batch of samples. In this case, we had the annotators Falco and Julius. Falco said Pech gehabt is negative, and the categories were Kunden unter 27, Ticketkauf, Logangebot, negativ Ticketkauf. If you compare that to Julius' version, it's totally different. He annotated Pech as negative Ticketkauf and alter Trick as negative Ticketkauf. And the comments below that are actually the ones from myself. I mentioned, well, Pech is also negative when you have no gehabt, and gehabt shouldn't be annotated, and Pech is in this case not an information that justifies the category Ticketkauf, so buying a ticket. I showed you this to give you a feeling how cumbersome can annotation be, and also in a business context, how costly. In our document generation process, this annotation process led to another issue. Again, I can't show you the real document, so I took a fairy tale, Hänsel and Gretel. Imagine the upper part is the clinical study report. We have a paragraph, and we traced parts of the paragraph back to the input documents, input 1 and input 2. But you realize there's part of the CSR, the purple part, which is neither found in input 1 nor in input 2. This led to the conclusion, our input documents do not contain all the information we need. So the information is not inherent to the data we have. It's somewhere else, but not in the data. So how to proceed? The project continued as follows. We realized that essential aspects had been overlooked as we were focusing too much on the machine learning part. But we had to think out of the box and ask explicitly, how is a medical writer approaching his job? With which steps does he or she start? And we went back to basics. We read, we annotated, we tried to mimic the writing process, and also searched for close contact to the customer to realize how he was working. And we focused more on extracting the expertise of our customer than getting real data and generated fake data in order to develop and test our algorithms. So this is already the first example. Coming to our next example number 2 was the Digital Engineer by Nitrexo. The Digital Engineer is a platform which is supposed to teach engineering students to build a satellite from scratch. I already explained that. And a chatbot guides the user through the learning experience. The domain knowledge that is given to the student, to the engineering student here, is very specialized. So there are no appropriate libraries available, and the database that was needed to build this chatbot had to be built during the course of the project. When we started, the database was not there yet. Also, different user questions depend on the exercises. So we could not foresee what kinds of intents could be entered into the chatbot before the rest of the project was already implemented. Other parts of the platform are not even related to NLP tasks. So there were visualization aspects and videos and so on. So it was an interaction between questions a user could have because of all the rest that was incorporated into the platform. So again, a strong collaboration between software and engineering team was needed. Here's a short example how it looked like. I added the typo not by accident, because a chatbot should also work when the user types typos into it. So here, a user called S asked what is Newton, and then the digital engineer tells, oh, it's the acronym of Newton, blah, blah, blah. And then the user said, thanks. And the digital engineer said, I'm happy to help. So some of these answers are Googleable, but others not, because we were gathering here the expertise of someone who was working in space tech for 10 years with a very specialized knowledge, and not all of these questions, not all of these inputs that should be given to the student are available by a simple Google search. Let's come to our example number 3. This has the specialty that it has not yet started, but it shows something that is very characteristic for NLP projects, predicting the health status of individuals. Obviously a classification task. Input data is labeled. It's initiated by a company who has the domain knowledge. That's very cool. Issue, the database does not exist yet. Again, so how to do anything with that? But the good thing is, as I said, the project has not started yet, and the responsibles were already aware of this issue and already planned how to label the data so that we can in the end have a proper database to train our algorithm. What do these 3 examples have in common? First of all, the data situation. In most of the cases, data situation not good. Second, a highly specialized domain, so publicly available libraries won't help you much. And the NLP aspects are not the only part of the solution. Even in the first example I mentioned, it's about document generation. We had to format Word documents, go into the formatting process. This actually has nothing to do with predicting the correct text parts to the correct place to the correct section in the document. So in all the 3 examples, domain knowledge was needed. Which leads to my main takeaway from my work so far. It's about intents. People invest because they see a problem which they want to be solved. And this problem is often not even inherent to the data, because data has no intents. People have intents. So the overall situation must be taken into account if you want to develop good software for a customer. Which part of the process is cumbersome? Is the domain knowledge inherent to the data? Or is it only stored in the brains of experts? If so, how to extract it from there? I found a nice quotation on the webpage of Technical University of Darmstadt, and I thought I should mention it here. One of the main problems in the design of intelligent systems is the so-called knowledge engineering bottleneck. Human experts master their respective tasks, but are nevertheless unable to communicate their problem-solving techniques in a way that would allow to directly transfer their expert knowledge into a computer program. So we have two kinds of people: the ones who have the domain knowledge once we start an NLP software project, and we have the ones who know how to code, but they don't have the domain knowledge. So if this expert knowledge is the starting point, where does this lead us? We cannot rely on statistical regularities because, as we have seen, in many projects, the data does not give all the information, or there is no statistical evidence that certain conclusions should be drawn out of the data that we have. So machine learning alone won't lead us to a satisfying solution for our customer. We have to follow rules as conventions of the domain, and most people want to interact with a solution because they know they have domain knowledge, and they are actually the ones that we can harvest to feed the software program things the data doesn't tell. So this would go into a human in the loop approach. Which leads us to one of the main ingredients, the team composition. Because we need, I couldn't resist, I had to put a picture of our team onto that. Because when it comes to NLP in business, it's not only about machine learning, it's about knowledge engineering and about where to get your knowledge from. So when all you have is a hammer, everything looks like a nail, but we have to make sure that our toolbox is more diverse because we want a software solution. We don't want an algorithm that makes a good accuracy. We want something that actually helps solving an issue for our customer. And when we build a team, we must not underestimate the background of people, because people are a bit like tools. They tend to do what they are hired for because they are nice and they are responsible and all that. But this is why a machine learning expert, first of all, if you don't tell him otherwise, he will go for machine learning approaches, as we did in the beginning, because we were told it's a machine learning project. Other people do other things first. For example, linguists tend to look for rules, but also this does not always lead to the end goal. So we have to make sure that key people in the development process is given the accountability to care for the product, not only for their tiny little bit of code. Product/intention, because in some cases it's rather an analysis than a product. And therefore close collaboration with the ones who have the domain knowledge is crucial, because natural language is usually just the carrier, not the knowledge itself. It's the tool we use to convey knowledge. And this is almost the end already. As a take-home message, I can give you this. A bad data situation must not be the end of the project. As you have seen in the first example I mentioned, it looked bad at first, but then we found a solution. But you have to think out of the box to achieve that. And the general trust in a machine learning algorithm sometimes hides equally important aspects, such as the information flow inside a working environment, for example. So when digitizing a profession that sticks to customized or analog processes, it is crucial to work interdisciplinary and do not lose the picture while digging in details. One example, we realized at one point while we were trying to predict if a certain paragraph was going to a certain section, at one point someone told us, well, actually every time I see the word X in the heading, I copy the whole paragraph or the whole section into the output document. Good to know. Then we only have to look for that tiny word. And this is something that you get out of a customer when you actually talk to each other. it saved us days, because an algorithm would have, well, we would have never been as courageous to hard code something like this. But when the customer told us, actually, this is how we work, we had the confidence to do so. So don't assume that your data set capture the whole situation. You need there's a typo, interdisciplinary thinking people in your team, also from a technical point of view. Everybody does that when you want to start a business, but it's not only like having sales, marketing, and business development. You also need interdisciplinarity inside a tech team. You need people who have their expertise in data science, in machine learning, but also people who go into the data with another mindset. So focus on the challenge, on the solution that you want to find for your customer, and not on the method. And of course, clear communication is always key, especially when you talk to the customer, because sometimes buzzwords are the enemy of your expectation management. And if you try to solve a big data, well, if you try to solve something with deep learning, but you only have tiny data and it doesn't work, it saves you months and also costs for your customer if you just try different approaches from the beginning. So do's and don'ts when starting an NLP project. The interdisciplinary team, I think right now everybody has that in his mind now after I repeated it so many times. It's key to bridge the knowledge engineering gap. We have to embrace the domain and focus on the user's needs, on your client's intents, on the process. And this also helps us then to manage the expectations. Sometimes a human-in-the-loop approach is not only good because it leads to good results, but also to give your customer control back. And this is something that people are often afraid of, to give all the knowledge to a computer and then maybe lose control. But when you give them the feeling that it's actually controllable, that they can trace back why certain decisions have been made, it leads to a more happy customer. Don't assume your solution is always adherent to the data. Don't let the methodology decide the result. Don't stick to trends. My tongue is already too fast. And don't stick to an NLP or AI solution if it turns out that your user actually needs a fax machine. Thank you for listening. So I think this is the end of my presentation, and we can continue with questions if you have one. I don't know, should I stop the presentation mode, Yasmin, or?
I think you can let it like this.
Okay.
And then, Celine will take some people who, yeah, does anyone have any question?
Yeah, Hannes?
Yeah, hi. Thanks so much for your presentation. That was really, really insightful. Especially you mentioned the presentation by Mr. Reimers. I forgot the first name.
Yeah.
And then the transition to the more applied stuff that you were now talking about. I was wondering, so for many data science projects in general, people say you spend around 90% of the time on collecting the data and doing pre-processing, and then 10% on actually like selecting and training the model and making sure this is really like the output you want. Is that also, would you say, for NLP projects in general the case, or do you actually spend some more time on selecting and training the language model because it might be more complex than the model used in, let's say, general AI projects?
It's difficult to say, because in a more general project, you can gather the data, but in some projects, in our case, in some projects, we were searching, we were asking, but there was not more data. So at one point, we faced a situation that we have to think in a different way, that we have to adapt some things with rules, that we have to interact with the customer, that we, for example, with a chatbot, in some cases, it makes sense to ask back so that you can get another input from the user. So 90% data gathering, no, not in our cases. It would be great. I mean, as a data scientist or as an NLP person, you always love to have more data, but when you don't get more data, you have to work with what you have and try to make a proper solution out of it.
Okay, great, thanks. If you allow one more question, so in other projects, especially if you think about computer vision, people work a lot with data augmentation. So they just lose some noise on the data and then have the labels already. Is that something that you use in your NLP projects as well?
No. In most cases, it's not possible because the language follows certain rules and we cannot just put noise over it. It might work for certain occasions, but in all the projects that we have, they follow so strict rules dependent on the domain that it's not possible to do work around with data augmentation. Oh, I said something like, okay, Google, obviously. We tried to use transfer learning with the clinical data, but in the end, it wasn't worth the effort.
Okay, thank you.
I would also have a question. Zara, first of all, thanks for the insightful presentation. And I would like to point out one sentence that really stuck to me is that natural language is not the carrier. Is actually just the carrier and not the knowledge itself. I think that pinpoints it. I wanted to know if you have any experience with synthetic data sets. So you said that it's usually really complicated to gather enough data. Is there any approaches at L1 that you tried already with generating data for specific model trainings, for example?
No. Well, not in the bigger projects. We tried something, but we, in the end, left it aside. The thing is that when it comes to knowledge engineering, when you want to get the knowledge out of the domain, how to simulate it without understanding what the knowledge is actually is. So actually, the synthetic data would have to come from the customer, at least when it's such a specialized project as in our cases.
Thanks. If there's not more, I have one more question. So what I would be interested in is also, you said that let's assume there is a customer approaching you saying, I want to do a machine learning project, and then you by the time figure out actually this is not really a machine learning project. So how do you sell that to the customer? Because I think he probably is looking forward to have a cool machine learning project, and then you're going to tell them, sorry, but actually that's not what you need. So how do you make this? Yeah, how do you sell this kind of?
You can show the data, because when you show the customer that there's too much variety in the tiny little data he has, and that for an algorithm to work properly, there would be this amount of data, and you can visualize that, you can show it in numbers, and this is actually something that is relatively easy to communicate. It's more difficult to communicate why it is then still cumbersome to find a proper approach, because many people have the idea that, oh, you just throw data on it and then magic happens. There's some weird AI doing something, and in the end, all my problems are solved. But in most cases, it's more complex. And also the term NLP is then used too broadly, because what most companies want is a software solution. It's a software development project then. It's not only an NLP task.
Thanks. Yeah, I can imagine that during the current hype times of AI and NLP and machine learning in general, that many people are coming with this idea of I need an intelligent system, and they just use AI as a synonym for software.
Yes, exactly. And coming back to that clinical trial project, I told you that part of the documents are tables. They are evaluated based on the numbers inside. Of course, the end product is a text, but this does not mean that it's natural language processing that happens when you evaluate the tables. This is actually just comparing numbers. But many people don't differentiate. They see, oh, it's text, it has something to do with natural language processing.
Thank you.
Any more questions? And Julie?
Hi, Sarah. Thanks for the presentation. I was wondering if you know, or probably there are metrics to decide if your NLP results reflect the content of the data set well or not. Because
I can't hear you anymore. Maybe the mic went off. Oh, we lost you.
Yeah, I can hear you again. Sorry, I think it was my connection. Can you hear me better now?
Yes.
Okay, thanks. So I was wondering, what metrics are there to analyze how well your NLP results match the actual data set? And is particularly regarding your quote that you said that it's all about the intent, not the data, or something like that. So are there metrics that measure how well your results actually catch the intents of a data set and not just the pure like data word kind of things?
It depends on the project totally. So there are measures for certain things. For example, standard thing would be accuracy or F measure that you can use for sentiment analysis. In the clinical documentation case, we actually let everything run through a manual control because it's very specialized and there's not that much data. In the chatbot case, it's accuracy. Yeah. It depends. For summarization tasks, there are different metrics. The standard would be F measure, but for more complex outputs, such as a whole document, it's difficult to define because we can give you an accuracy for the text if everything was properly predicted. But on the other hand, if the formatting is totally off and the table is not formatted in a certain way, this has then nothing to do with NLP, but it destroys the whole end product.
And are there domains where you would say it's so hard to identify the intents of the language data that this domain is not at all suitable for NLP techniques?
Hopefully not. I'm still optimistic enough to drive forward. Of course, there are some situations where you think, I'm not totally sure if it works in the end. If it's very abstract and you have no idea at all. Clinical research is kind of approachable, but there are also other domains that are more techy and very abstract, for example, on how engineers in space tech structure certain work processes. And there are things where I'm not totally sure, but I'm still optimistic.
Okay, that's good to hear. Thanks.
So, no one else?
I maybe have one more question. I was wondering, like this GPT-3 hype last year was really big. Is there anything comparable for German language actually that is usable? Some kind of, I don't know. There's lots of stuff on Hugging Face, but I'm not sure if there's actually good German language models that you can use.
Not to my knowledge. But for our project, it's not really useful because our customers have very specific needs. And so everything we tried out so far, it was not of any use for our project. And yeah, the industry works in English. Most industries work in English, especially those which invest in NLP projects. But most of these projects take longer. It's not like doing a web page for 1 month or something. It's usually an investment that takes longer, and the trend goes to English.
Then I assume hessian.AI, and together with L1, we will have to build a model up then.
Hessian corpus. We can also include dialect.
Yeah, that would be fun.
Cool. Thank you for your questions so far. And thank you for having me.
Thank you so much, Sarah. Thanks. I have learned a lot today. Yeah, if there aren't any questions, or do you have any questions, so do not hesitate to ask Sarah or write us. It was great, Sarah. Thank you so much.
Thank you.
And thanks for all the questions. And then have a good evening.
You too.